So we have a sample problem here for a Ka problem. Now, in this case, the question reads, if Ka is equal to 1.6 times 10 to the negative 6, and the concentration of the acetic acid is 0.23 molar, what is the hydronium ion concentration in the following equation? And here we have the balanced chemical equation. Remember, for acids, it's always going to be a 1 to 1 to 1 to 1 ratio. So the first step is we have to write out the Ka expression. So we have Ka, just like KQ, it's products over reactants. So this is an AQ, so I'm going to take the concentration of hydronium and then multiplied by the concentration of acetate, which is this ion here. And then I have the reactant, the acetic acid itself, COOH. All right. And I do not include the water because it is a liquid, and you never include solids or liquids in any KEQ problem. Now, in this case, I have the Ka and I have the acid concentrations, and I'm trying to find and I'm trying to find the hydronium ion concentration. So I'm trying to find this guy. Now, if you remember, since these guys dissociate, it's a 1-to-1 ratio, the concentration of hydronium is going to be equal to the concentration of the acetate ion. So what I'm going to do is since I'm solving for those, I'm going to pull a trick from algebra, and I'm going to say, all right, this is what I'm solving for. I'm going to make that x, just as a placeholder. All right. And since if that's x, that means that is x as well, right? They're equal to each other. So therefore, that's x. Now I have numbers for here and here. So when I plug them in, I see that I have 1.6 times 10 to the negative 6 is equal to x times x, which is x squared, over the concentration on the bottom, which is 0.23 molar. Now I want to solve for this, right? So I'm going to multiply. I have to get rid of the 0.23, so I'm going to multiply both sides by 0.23, 0.23. So I'm going to multiply those. Those are going to cancel out. And then those two times each other will give me x squared. I want to find just x, so I'm going to multiply those two together and then square root both sides. All right. So on my handy dandy calculator, I'm going to go and I have, let's clear that, 0.23 times 1.6 negative 6. I'm going to push equals, all right? And now I want to square root that. So basically, I go to the little square root button here, second, square root, my answer. So I go second again. Down on the bottom, I have where it says answer. So I do that, I square root my answer, and I push enter. And that is my final answer. This is going to be equal to x. And if you notice, I have two significant figures there and 2 there. So I want to round this off to only 2 digits. So I have x, which is, remember, the concentration of H3O. That is going to be equal to 6.1 times 10 to the negative 4. And it's a concentration, not a Ka, so the units are M. And that's my answer. Okay. So problems that ask for, they give you the Ka and ask for these, you do it like this. Some of the problems will give you the concentrations of all 3 of these and ask for the Ka. Well, those are simple. You just plug it into the expression, multiply, then divide, and you get the Ka. But that's how you do a typical Ka problem.